Hello, good evening, and welcome to LinkedIn's second Engineering Productivity Tools Meetup. If you are here for the first one, it was a great success. I hope this one goes as well as the last one, and we have a set of great speakers lined up today. So let me first introduce myself. My name is Jenny Gao. I am responsible for presentation infrastructure here at LinkedIn. My team is responsible for the web framework, the API framework, as well as accessibility and translation here at LinkedIn. I work closely with the tools team, the developer productivity team. I'm here to help them introduce all the cool speakers we have lined up today. So before I get started, here are some housekeeping items. First, bathroom is out the door to your left with a big old sign. You can't miss it. Also, if at any point during the whole show, if you have any questions, if you're wondering how LinkedIn do certain things, find one of the people with a blue badge or wearing a LinkedIn t-shirt, right? Ask them these questions, introduce yourself, network, get to know each other. We're friends. Next thing is that there is a booth over there that LinkedIn is providing complimentary professional headshots. Look at mine. I got that done. So you can actually get one and put it on your LinkedIn profile looking all pro. So feel free to take advantage of that. Also, there will be a Q&A session at the end after all three speakers presented. So hold your questions till then. We'll have all the speakers here up on stage and you can ask them all the questions. Cool? All right. So why developer productivity? So at LinkedIn, our mission here is to connect the world's professionals and help make them more productive and successful. We recognize that in order to achieve this mission, we have to be productive ourselves. But common sense, right? If we're not productive, how can we help other people? And also, this is a fun fact. Well, not so fun if you're a hiring manager or you own a tech company. But engineering is the single biggest business investment causing any technology company, right? It's not the fancy, expensive buildings, not the data centers, not the free food, not the crazy perks, you know? It's the engineering salary. That's our biggest business investment. So if you can help these engineers be productive, be efficient, operate fast, do their jobs, then you're not really protecting your biggest investment. So something about myself that recently, so I'm not a very handy person, right? Recently, I was introduced gently by my partner to power drills when I was trying to install a curtain with screwdrivers. Right? So it took me 30 minutes to install each curtain, but with the power drill, I could do it in 2 minutes. Wow, that was a life-changing experience, right? So point of my story here is like, we here in this room are in tools, infrastructure, productivity functions, and it's really our job to ensure that developers are empowered with power drills and not, suffering and trying to accomplish their goal with a screwdriver. All right? Okay. So here at LinkedIn, engineering productivity is a high priority. We have teams that are dedicated to it. We have initiatives that work on improving engineers' productivity, happiness in general. And here today, the goal of this event, right, is to share some of our findings and learnings, and also to learn from you, the industry experts that has been thinking about this problem and trying to figure out how to improve your organization's engineers' productivity. So I'm here to basically introduce the speakers, and here is the first one. Excuse me, my notes. It's Nadav Kohen. He's here to present Nuit, the next generation of developer tooling at Netflix. Nadav currently leads the Nuit team at Netflix, focusing on improving developer productivity and velocity. And he previously worked at Netflix, including productivity tools related to build, dependency insight, collaboration, and documentation. So please join me to welcome Nadav to the stage.
Thank you. All right. So thank you all for coming in. Thank you for the kind introduction. Hope you're enjoying the food. It's amazing. All right, and let's begin. Okay, so today we're going to talk about a tool we built at Netflix called Newt, or Netflix Workflow Toolkit. It's something that we built in order to support our polyglot efforts within the company. But we do this while enabling our developers, not to worry so much about the internal plumbing work that needs to be done as part of that development. So that means stuff like initializing new projects, packaging your stuff into deployable units, publishing to an artifact repository, that sort of stuff. We just kind of make disappear as part of the tool. The cute little mascot there that you see is our logo. We have stickers of that thing, so please feel free to come by and grab some after that. Also, ask questions if you have them, but this is probably more important. Okay, so before I start talking about Newt and why we built it and how we built it, I think it's really important to explain where we came from, what state Netflix was in before we came up with Newt, and what reasons we had to actually come up with it. It will give you a good context and a good understanding, I think, of our thinking at the time. So back in the 90s, when they founded Netflix, more or less, we had a lot of cool things. We had Friends, right? That was kind of successful back then. I think it's actually still successful, surprisingly. But people really love that show. We had this thing, right, that also was very successful. It was kind of revolutionary even at the time. I don't know. And then we had this thing. It was like some small company that was basically sending out DVDs to people through mail so they can watch it on their DVD player at home, right? It maybe sounds a little bit absurd, but that's the way Netflix started. It still exists today, but in a more limited capacity, but it still exists. And as you can imagine, this sort of endeavor didn't really require a lot of sophisticated technology, right? Back then, we didn't really talk about the cloud. We didn't talk about microservices. We definitely didn't talk about polyglot. It was effectively just a big Java-based monolith, right? That was using an Oracle database backed in a data center, right? That was the thing we had back then, and it worked great, right? For what we needed to do, it worked superbly. And for us, as a development tools team, it made sense to use what we call the native tooling that went along with the JVM, right? So that was what developers expected. That was the easy thing to do. So we started off with Ant. I don't know if anyone uses Ant still. Yeah? Sorry to hear. And then we moved on to Gradle, which is the de facto tool nowadays. Okay? And as time went by, we built more and more infrastructure that was part of that process. Stuff like code for building. So what's the project structure and how does it end up? How do you test this thing? All sorts of metadata that we added on top of it, like what kind of dependencies you resolved or what operating system you built this on. All sorts of metadata that really made sense for the entire organization. We talked about packaging, so we take that artifact, we turn it into a package. We didn't want everyone to do it themselves. And then publishing to our artifact repository, and finally, and maybe very importantly, we had metrics for everything, right? We wanted to measure and gauge all the things that people were doing so that we can improve upon that. If we don't have the numbers, obviously we can't really do much. We can guess. So over time, I don't know, maybe some of you have heard this before, all the tools matured into what we now call Nebula, which stands for Netflix Build Language. It's a set of Gradle plugins that are mostly open source that effectively enable all the things that I just talked about. You can get it on GitHub if you want to, if you're using Gradle and that thing is useful to you. In fact, we were using Gradle so much that we got to a point that we had to hack the actual Gradle distribution at one point because Gradle core was not good enough for us. So we hacked the distribution and we started distributing that internally at Netflix. It worked, right? As long as we were on the JVM mostly and we didn't really have to venture into other territories, that was fine. It worked really well. But then, obviously, developer needs started to change. As Netflix grew more and more complex, so did the tooling, and people started asking for new technologies. People wanted to use Node. People wanted to use Ruby for the quick iterative development for UIs, right? And with Java tooling, we could support it to an extent, but it wasn't ideal, right? They just wanted to use more. And here's a chart that shows language use at Netflix over time. This is up until 2016. It's not super updated, but I think it shows the point. You see that initially we started with mostly JVM and nothing else. And then over time we grew, I don't know if you can see it here, but the top green line is JVM. So it grew, but so did other languages. The second line there is JavaScript, and then we have other stuff like Python and Ruby and more languages started popping up. So obviously Java was still important, but it wasn't the only one anymore. It wasn't the only player. And looking at it from a different angle, you see, like relatively speaking, that Node or JavaScript is actually almost as big as Java, right? It's something that happened kind of underneath the radar. No one really asked for it explicitly, it just kind of happened. And we've been hearing more and more chatter about it. And so you see we have a lot of different technologies here. We have JavaScript, which is a combination of our complex UIs and also backend in Node. We have stuff using Ruby and Ruby on Rails for UI development, or fast prototyping rather, and then Python for machine learning and data science, right? So everyone have their own kind of tool. So obviously, developers still needed to package stuff and publish stuff, but they still wanted to use those languages. And they didn't have a built-in solution other than Nebula. So, developers being developers, they didn't want to reinvent the wheel. So obviously what they did is they hacked around it, right? They found solutions that worked for them. And I want to go through a couple of solutions that we have seen at the company, before we were able to address it. And I'm sure some of you could relate to what I'm about to describe. So the first polyglot hack that we've seen has to do with building Node apps. Okay, so in this case, what people basically did was they completely disregarded their tooling. They said, all right, I'm going to install Node and NPM locally on my machine. I'm going to make it work. I'm going to test it locally. Then I'm going to push it to Git. As soon as it goes to Git, Jenkins pulls it as the CI and then does all the magic. It runs the script there with whatever version of Node and NPM they have there. Then they call some other script that calls Nebula, that packages and publishes. And then, sometimes it happened. It worked, sorry. I like to call it Jenkins as glue because all that magic happens on Jenkins and no one really knows how to reproduce it. But that's the way it was. And obviously, it's not an ideal scenario for many reasons, but I think first and foremost, there was no way to manage the versions of Node and NPM, right? And so they had some version locally on their development machine, and then maybe another developer would have had a different version. And then on Jenkins, they had something else, unless someone upgraded Jenkins and then changed the version for them. And then whatever ended up being packaged on the Debian, the package, also maybe something completely different. So, there was a mismatch there that led to oftentimes to really weird problems. People obviously complain, hey, this worked on my computer. I don't understand why it's not working in the cloud. It must be Amazon's fault, right? And the second thing here that's problematic has to do with the fact that they had to use Gradle as glue. Right? Node developers, generally speaking, they're not super familiar with Gradle because they don't have to. And so what ended up happening was they kind of just copy-pasted, working scripts from other places. And so we ended up with a lot of replicas of some script that someone wrote who left the company a long time ago, and no one really knows how it worked, right? It just kind of worked until it didn't. And then it was really hard to fix it because no one really understood how it worked, and there was a lot of lost tribal knowledge in there. And then finally, maybe less important is the fact that you had to have both build Gradle and the package JSON and multiple types of basically build tools in your workspace. It's not, it's not super clean. It's not something you'd want to have if you want to maintain a clean repo. The second thing, somewhat better, second hack is somewhat better, not ideal either, is to basically use Gradle as the UI for everything, as the interface for everything. Okay, so what they did was if they wanted to call npm install, they'd call a Gradle task. The Gradle task would call a Gradle plugin that would download npm, that would call npm install on your machine. So at least that solved the problem of having separate or different versions of Node on your development box and Jenkins, but then you had to use Gradle to develop a Node, right? And so I'm sure you all know that Node developers are very accustomed to instant feedback and everything runs super fast. Gradle does not provide that. Yeah. And secondly, we still had the problem of lack of Gradle expertise, right? Even if they still use Gradle as the interface, it still wasn't something that they felt comfortable with, and it left us with inconsistent solutions at best, right? Okay, and to add on top of all this, we had more problems that resulted from all that hacking because we had more and more use cases as technology selection grew, right? We had cron jobs, multiple languages for cron jobs. We had Python, we had Ruby, we had Bash. We had a bunch. We had Lambda type work, so functions. That's also something that started appearing. Documentation sites, a completely different problem. And so on and so forth. Not to belabor the point, but really all of this made for a really, really messy development environment, given that everything was based on Nebula. All right, so just to sum up the problem, we had a big lack of consistency with our repos. People repeated work left and right just because they had copied paste or they didn't know what everyone else was doing. There was no central guidance. As a result, there was a lot of tribal knowledge that was lost over time, leading to errors and difficulty to fix things because really no one could find the person in charge. We lost the telemetry, which is a big thing for us as a centralized team. They weren't using Nebula or Gradle anymore, so we kind of lost that. And then, obviously, bad user experience. If you have to run Gradle every time you run NPM, it's going to be slow. People were not happy. All right, time to talk about the solution. So our solution, just like any other good programming challenge, was to use abstraction, right? Always abstract things, always add another layer of abstraction. It always solves things. That's what I learned. So first of all, we realized that basically everyone, no matter what platform you're developing against, everyone uses the same type of commands, right? You always have to initialize your project. You always have to build. You always have to test. You always have to package and publish, right? There was always some subtle differences. Like, for example, if you packaged a Node project, you had to have the Node runtime in your package. If you package Java, you were dependent on Java, those sort of things. But generally speaking, it was the same kind of verbs, same type of commands, except small differences, okay? So we came up with this model where a command is essentially a repeatable implementation logic and some config on top of it. And we can look at a couple of examples now that would simplify what that means. So looking at the, can you read this, by the way? Is that okay? Thank you. So looking at the package command, for example, this is where we take binary artifacts and we convert them to a Debian package. Okay, this is what we later push onto the cloud, and we bake on top of our Amazon machine image. And that is what we call the immutable infrastructure. This is the thing that we later use to deploy on Amazon. Okay, so we need to package things as a Debian. So we have the package command. We know that there is some config, and we need the reusable code. And as I'm sure you've already realized, we have already implemented that code in Nebula, right? We didn't want to re-implement this. So what we ended up doing was to make that code available by means of a container. I'm sure everyone is familiar with containers, right? I don't need to explain containers, good. So effectively, containers are an isolated process, right? It's a way for you to execute code in an environment that you know exactly what it contains and how it's going to run, right? And it's repeatable every time. So what we did in this case was we created a container that contained the Java runtime, our Nebula code, the Gradle distribution, and all the things that are needed to read from the config how to package something, and then to package it. So we execute the container, it runs, it packages, and then the container goes away. And the advantage here is that the user who runs this command doesn't even know what ran there. They don't know if it's Nebula or Java. In fact, they don't really care. It's just an implementation detail. All they care about is that they have that config, and that, that takes care of everything. Okay? Taking a somewhat different command is how we do initialization. So previously, before Newt was a thing, we asked developers to install Node and to install Yeoman, which is a code generation library, and to install some module and then run some Node scripts to generate their code. Obviously, that's a lot of work. There are many ways where this can get screwed up. And so what we ended up doing was we created an initialization command that had its own config, where you'd config what type of project you want to initialize, what you want to call the project, that sort of thing. And then we'd launch the container that comes this time with a completely different set of dependencies. This time it came with Node and Yeoman and some glue code. And the container knew how to read that config. And so again, we execute this. It generates whatever you need to generate, and then the container goes away. Again, the user has no idea what the underlying technology is, but we didn't have to reinvent anything. We just kind of abstracted away all this logic within a container. Okay? And a final example, this one uses Python, is the way we do documentation. So one of our efforts for us as a centralized team was to push developers to write documentation in Markdown. Okay, is anyone familiar with MakeDocs? No? Just one? Two? All right, thank you. So MakeDocs is basically a Python library that allows you to take Markdown code or Markdown documentation and convert it to a really nice looking website. The problem is that you need to have the Python tooling. You need to have Python installed. You need to have the Python module installed. You need to know what to run. It's not super easy. But once you have all that stuff configured, creating beautiful looking documentation sites is really easy. So we wanted to encourage that, and we did this through this command. Effectively, again, they'd call the MakeDocs command. We would delegate to a container after mounting the current workspace to the container, generate the site, and then again it goes away. Okay, so this is where Newt comes into the picture. Okay, that's the mascot again. So Newt is effectively a really small, lightweight Go binary that we built that knows how to read a configuration file. You see it there, it's a .NET YAML. And based on that configuration file, it knows what commands to expose to the user and what their basic configuration is. So in the Newt YAML, you'd say, I want my project to be called this, I want my build steps to be that, and then Newt kind of knows how to do all the things by orchestrating the different containers or other tools it knows how to use. The way we do this is basically by having Newt know how to install dependencies for you. So for example, if one of the commands requires Docker, so Newt installs Docker for you. If it requires NPM or Node, it does that as well. Okay? So what do we have so far? We have reusable code in the form of containers. We have pre-configured environments, so we know every time we run those commands, they're always going to run the same way, right? It's not going to change. It's not going to vary based on whatever they have installed on their computers. We have really simple configuration. It's just a YAML file. I don't know how many people here use Gradle, but comparing to the Groovy DSL, it's night and day. It's super simple. It's very fast because it's built in Go and it works natively on all the different platforms. And finally, we get our telemetry back. Again, users are using a single tool. Again, they're happy with the single tool. We get the telemetry. We can now act on it. We can now improve the development experience even further. So, is this good enough? No, because then I'd have to finish this presentation. I have more. So this is good. We have some level of customizability. The problem is that when you have this level of customizability, you're guaranteed that people will customize it a lot more than you intend, right? People will just say, oh, I have this just one thing I have to change, or maybe my configuration is a little bit different. And so what this ends up doing is that it creates more confusion, right? It's just, you get more inconsistency across the board. And it's very hard for us as a centralized team to encourage, what we consider best practices or the paved road, okay? So what we ended up doing to kind of fix this situation was to introduce another type of abstraction that we call app types. An app type is effectively just a way for us to group a certain set of commands and defaults that make sense and represent what we consider best practices, okay? So you'd have an app type for Node, for example, that would have the init, build, test, package deploy thing, package publish, and you'd have something completely different for a Docker-based project, right, where you build an image and publish it to a registry. As I'm sure you imagined this already, this is what it looks like. You just specify in the new YAML the app type, and then you inherit all those properties from our centrally managed definitions, okay? So it's not pure inheritance. You're not going to have double inheritance and stuff like that, but at least you get the blueprints easily, and you don't have to kind of reinvent the wheel every time. We get the consistency, and we get to push our paved road recommendations. So let me just give you 2 quick examples for what this looks like. Yeah. So for node projects, again, we have one sample of such node project is to use init, which again delegates to the node and yeoman container. And then we can build using whatever they define for node and npm. Then we can run a preview from a local container because we have Docker installed. So we can generate a replica of what the cloud variant would be. And we do it locally, we test it locally. We can package as a Debian, and we can publish, again, to the artifact repository. The docs project I talked about previously, again, you initialize using some other method, doesn't have to be Yeoman, actually. You can do local preview from inside the container. You build, and then you publish, again. And there's a bunch more, but I don't want to bore you with all the details. I just want to show you a quick demo of what that looks like. And this is basically the demo for the documentation site. What we're going to do is we're going to edit a documentation site in Markdown. And we're going to see what happens, how the local development experience looks like with respect to the container. Is that working? Okay, so we have a browser and 2 terminal windows. In one terminal window, we're typing newt serve. What this does is it launches a container with the makedocs tooling. It comes with Python, makedocs, and all those things, and it launches the live preview server using the files from your laptop. And then using the browser, I can actually see the live preview. In another terminal, I can edit the documentation. And you see that the container was able to pick up that change and update my browser real time. And again, on this computer, I don't have any Python installed, no makedocs, no anything. And this is where it shines, I think. All right, so with app types, we can encourage best practices. We simplify the tools and the processes because people don't have to install anything anymore. It's just, they don't have to think about what commands to specify. It just comes with the app types. We have some level of customizability, but we control it, right? We say on the app type, what are the things that we want people to customize? For example, the project name, or where you want to install it, or what do you want to call the package, stuff like that. And maybe most importantly is that we now centrally manage this, right? Instead of having people kind of do their own thing and copy and paste code, left and right, we now control what that blueprint looks like. And that really helps us with pushing people forward and doing what we consider the best practice. So not everything is great in Newt land. There are some things that we are trying to tackle right now, some things that we didn't anticipate. For example, some people call Newt a kitchen sink tool, right? Because it's so easy. Everyone's using it. It's the UI it's the interface for everything. So, naturally, we're going to put AWS credentials code in there, and naturally, we're going to put, VPN check code in there. I mean, why not? But the problem is that, it's growing bigger and bigger, and at one point, kitchen sink is not usually used as a good term. So this is something we need to balance. I mean, how do you balance, a productivity versus, something that's bloated? So that's really something we're kind of trying to figure out right now. Something else that we're dealing with is what I call configuration drift. After people have generated their project and they're happy with it and it works on the cloud, things change and we need to upgrade libraries, we need to tell them to change things. It's not always easy. Sometimes it's a configuration thing that we can control from the app type, but sometimes we really need to change code. But then you have to find the person who's in charge of it if that person is still in the company. You have to make sure that they deploy it and it doesn't crash in production. And obviously you as a centralized, well, we as a centralized team, we can't really own all of those things. We can't own all of the services, okay? So this is something that is quite a challenge for us and we're trying to address. I don't think it's unique to Newt. It's what people generally call change management. But because everything goes through Newt, is something that we are facilitating right now. And then this is a really interesting problem. So the way Newt works today is it auto-updates itself all the time, right? It's a self-updating binary. So you always have the latest version, and you always have the latest version of the app types, which works great for us as a centralized team because we know they are always going to have the latest version. We know they're not stuck, somewhere in the Stone Age. The problem with that, and rightfully so, people are asking for reproducible builds. They want to know that something they built a year ago would build in exactly the same way today. It's totally fair. So this is something we need to balance. Like, how do we give them that possibility, but also make sure that they don't stay stuck there for years on end? We're a small-ish team of 3 engineers. We can't really support everyone, and we can't really push everyone forward all the time. And so this sort of thing is something that we need to figure out. Perhaps I should also mention this. At Netflix, generally the culture is that you can't tell anyone what to do. And so even if they decide to stick with one version, it's their call. And so we need to find that balance. All right, so what's next for Newt? There's a bunch of interesting things that we're going to do. So first of all, now that we've abstracted away the commands, we have the option of completely changing them, right? It's just an implementation detail at this point. So for example, the package command that I talked about leveraged Nebula and leveraged Gradle under the hood, which is okay. It works okay. It works pretty fast. The problem is that the Nebula build is reliant on some third party that hasn't been updated in a really long time, and they have really long overdue bugs that no one wants to address. And so what we want to do is we want to change the implementation, and we're doing it through a different mechanism called DebHelper, which is the native Debian way of packaging things. And we can do this because, again, it's just an implementation detail. So that's interesting. With respect to workflows, there is a bunch of stuff that we have just started thinking about, which I think is really exciting. Stuff around source control management. So, checking out code, creating branches uniformly, doing PRs, doing code review from the command line or from the IDE. There's a bunch of stuff that we could do there that could really facilitate the workflow for developers, stuff that we haven't even begun to explore. UX across the board is something that we're deeply passionate about, and now that we have metrics, we can actually address. And we hope to do stuff like IDE integration. I've heard that at LinkedIn they have IDE plugins. That sounds amazing to me. That's something we definitely want to look into. We're thinking about doing UI for project generations. So instead of using the command line to create your projects, just go to some UI and do all that instead of having to download things. There's a bunch of stuff that we could do. And then all the change management stuff is a really big problem that we need to address. Not quite sure how yet. I don't know if anyone has any solution that they've used successfully. By all means, please tell me. I'd love to hear. Okay. It's not working. All right. That's all I have for you. I don't know if you have time for questions. I hope we do. If not, by all means, feel free to talk to me. If you want to talk to someone knowledgeable who actually knows all the technical aspects, there's Josh here. I'm sorry, I'm going to embarrass you. He's one of the engineers on the team. Please feel free to talk to him about any questions you have on a technical level.
We will have a question and answer section after all the presenters, and we'll have you guys all come back on the stage. Josh, welcome too, and everyone can ask questions. Is that okay? Cool.
It's for me.
Awesome. So thank you so much, Nadav, for introducing, talking about the problems and challenges that you guys experience at Netflix and introduction of Newt and the evolution of it. It's really incredible and impressive to me that you guys done this with 3 engineers. So good job, and thank you so much. So next up, so LinkedIn has one of the largest iOS app, right? Large in the sense with number of features in it and number of developers working on it. So we have Oscar, make sure I pronounced this right, Oscar Bonilla here to talk about building a scalable iOS mobile web. And he's a staff engineer from the iOS build team. Come on.
Thank you. So as you can read in the slide, I work at LinkedIn with the iOS mobile build tools team, and we are in charge of building the iOS app. So since I only have 10 minutes, I'm not going to go into as much detail as Nadav went in the previous presentation. So I'm going to try to keep it simple and to the point. So I'm going to try and define what iOS at scale means, because that's sort of an overused, like if you want to make something interesting, put it at scale at the end, right? Whatever at scale. We're drinking beer at scale. So, and then I'm going to talk about the challenges of developing at a large scale and some of the LinkedIn solutions, like what we've done to cope with those challenges. So what does it mean for an app to be large? I'm talking, so the LinkedIn app is over 1 million lines of code. We were one of the early adopters of Swift. You know, we looked at Swift and said, ooh, shiny, and jumped on the bandwagon almost on year 1. So we've been dealing with Swift for a long, long time. That has impact on the build times of the app. It has impact on the code, how the teams communicate with each other, and that sort of stuff. Also, when you have to do transformations, the Swift language at the time we adopted it was very, very young, and it was not clear where the language was going to evolve to. So Apple kept changing it. And when you have a little app that's like a flashlight and they change the language on you, it takes you like a weekend to, you know, change all the things that, oh, they made like flat map, is compact map now, whatever. It's fine. But when you have an app that has 1 million lines of code, that gets pretty interesting. On top of that, the LinkedIn team is over 100 developers. So it becomes complicated to decide what they're doing and to decide on the features and to communicate. You don't want to be rewriting how you do some stuff while the other team is rewriting the network stack and then need to put them back together. We also have a large number of commits per day because we have that many people. And then what ends up happening is that things that only happen 1% of the time or 0.5% of the time happen all the time, and we have to deal with them. So those are sort of the challenges. I'll tell you some war stories later on. And then we also have to deal with testing, and nobody ever deletes a test. They are strictly additive. So we have over 1,000 UI tests, and if you just run them, like Apple wants you to run them, like you click test and Xcode, it will take over 13 hours. So that's no good. So we had to deal with long test times as well. So that's sort of the context for what a large app means. So what are the challenges? So I tried to divide them in 3 broad categories. One is people challenges, because so many developers working on the same thing need to organize somehow. The second one is infrastructure challenges, because at LinkedIn we run our own data centers, we have our own hardware, so we have to deal with the machines themselves, and iOS apps can only be built on Apple hardware, so that makes the problem. If you have a large data center that has thousands of machines, that is complicated in and of itself. If those machines are Apple machines that were designed for a consumer market and not for data centers, that makes it even more interesting. So there's a bunch of challenges there. And also the software, all the tooling, all the, how do you build it, how do you package it, the compilers, the linkers, the AC tool thing, the IB tool thing, the assets, the simulators. I could go on and on, but I won't because we don't have enough time. So the people, basically you can imagine what the problems are, these are the normal problems of large teams. How do you communicate among the teams? How do you share documentation? How do you do the code maintenance? That picture is actually a real picture of LinkedIn developers dealing with our Swift 3 migration party, which was basically take the million lines of code from Swift 2, make them be Swift 3, and Xcode very helpfully provided a tool that was supposed to automatically transform your source code, and it crashed because we had millions of lines of code and it wasn't expecting that much. And we strive for maintaining the feel of single author. So, that's sort of the ideal. You'd want to look at the code and imagine that a small team of 2, maybe 3 people wrote the whole thing in a weekend and it has self-consistency. But we have 100 or more developers. So maintaining that single author feel across such a large app becomes very, very challenging. Infrastructure-wise, that's a pic of one of our data centers. And mainly the problems revolve around, it's all the normal problems that running a large data center usually involves, plus machines not really designed for data center use. The standard Mac for a data center is the Mac Mini, because it's the only computer that Apple makes that doesn't have a display built into the computer. And people have done crazy things like taking iMacs and rack mount them on the side and all sorts of, but we stuck with the Mac Minis, and even those have very interesting challenges. Like you basically have to hit Command R for this operation. And you're like, oh, how do I hit Command R on 1,000 computers that don't have a keyboard attached? So we had to come up with some creative solutions, and I'll talk a little bit about those. As far as I know, there is any kind of lights out management for Mac Mini, so we had to deal with that as well. And software upgrades are really, really fun to do across thousands of machines. You can easily imagine that. And then we have all the tooling, right? Like, we have this weird thing where if you have a generic in Swift and you look at it from an Objective-C thing, whatever, the thing crashes. And that only happens 0.5% of the time, and for us it happens all the time. And we had this really fun bug where you had basically 1% of the builds were failing because chown was saying the user doesn't exist, but the chown right before it worked with the same user. And we ended up finding that it was a combination of an invalid group that crashes Open Directory D, and then if you do a chown while it's crashed, but before it restarts, that little window, then it fails, right? So it's one of those that you could never imagine until you see it. Also, producing metrics is a problem because when you have such a large, all of the machines are in different states, and you run a build, and this machine happens to have been running something else. Like you need to know to disable Spotlight, for instance, because otherwise it goes and touches all of your files. And just finding the right combination and making sure we understand what's going on in a global view, not individual machines, requires having very precise metrics. So that is hard. Reporting becomes a problem as well, because you can have different kinds of failures. When you're running a CI system, you can have failures that are due to the team's problems within the code that the team owns. Like, they make a mistake, they type something that doesn't work and shouldn't work, and then you want to communicate back what they did and how to fix it. Other times you have infrastructure failures, like they hit a machine that happened to have a busted version of Xcode installed, and then you want to communicate that clearly so that somebody can take a look at it. And in the millions of lines of logs that you end up, it's not a good solution to go back and say, here's the log, you find it, right? Because nobody likes looking at those things. Tooling upgrades become very, very problematic. Speed of builds as well. We have been dealing with slow build speeds and trying to speed that up, and I'll talk a little bit more about it. And also lots and lots of tests. And we have had a lot of trouble dealing with flaky tests, and I'll show some solutions. So I'm going to go back to the three broad themes and just talk about some of the LinkedIn solutions that we have. So the first one for people is a lot of communication. Our philosophy is you can't over-communicate. So basically, keep everyone involved, keep everyone in the loop, talk about what you're doing, show the projects, share the metrics, share the state of the projects, basically have a culture of complete openness and transparency so that everyone knows what's going on. Because even after you told everyone what you're doing and you're blue in the face of saying the same thing, somebody will show up and go like, I didn't know you were doing that thing. Like, this took me completely by surprise, even after tens and tens of emails daily saying I'm gonna do this. Yeah, I'm gonna brush it up a little. On infrastructure, the infrastructure side, basically the solution is automate everything. Nothing needs to be, if any step is manual, then it absolutely won't work. So basically we treat the infrastructure as code. It's a product that gets built, tested, and deployed in the same way as all the other products. We have, for instance, one piece of code that's called OVHC, the onboard health checks. And it's basically a daemon that keeps running. We built this thing, it keeps running on the machine, and it checks for all sorts of things. And you can, it's like a plugin-based system where you can add a bunch of checks, and it'll go and make sure that you have the right version of Xcode, the machine has the right version of macOS, that Spotlight is disabled, that all of these preconditions to it being a healthy machine are met, and then it can check this before a job, after a job, and it basically manage the whole thing. And that in and of itself is also deployed through the same system that we deploy everything else. So it goes through code review, and we have a standardized system for doing that. And then for tooling, a lot of wrappers. Almost everything gets wrapped around things where we will do things like make sure that if it fails, it gets retried, because sometimes there are some cases where just retrying works, but then we have to make sure to add it to the metrics that this thing got retried. So if it gets retried too many times, then we need to go look at it. We have a unified system for metrics that is for across the company, so we plug into that thing. Happy Build Failures is this broad initiative where we're trying to actually make sense of the error messages so that they're actionable and people can look at them and go, oh, I know what's going on, right? Then the process around upgrading, we basically found that having multiple versions of Xcode installed on the same machine doesn't work as well. And I talked to the Xcode team recently, and they've fixed this to a certain degree, but we just went single Xcode. It's like single malt. You don't want to mix your malts. So we went with the single Xcode per machine solution, and that has worked pretty well for us, to the point that we don't want to go back even if Apple fixed it. Then we're also doing we're switching the build system. This is kind of, change the engine while the car is running. We're moving from Xcode to Bazel because it basically buys us the build caching. Bazel is a build system that it's like an open source version of Google's Blaze system, and it has this property where it can run the commands in a hermetic fashion. And if they're fully determined by the inputs and the outputs, you can actually put a build cache, and for a bunch of stuff you don't need to actually build it, you can go and fetch it from the cache. So you make the builds really fast. And the screenshot that you're looking at is another tool that we built. It's called Bluepill. And what it does is that it allows you to run multiple simulators in parallel. And we run a bunch of simulators in parallel. Every execution takes over 4 machines, and every machine runs 5 simulators in parallel. And the only limit that we have on how many we can run is the number of cores in the machines. Now that Apple has released new Mac Minis that have 6 processors, so that's 12 cores, then we will run 12 of these simulators in parallel. So we're going to make our tests faster that way. And this tool is actually pretty nice because it also deals with flakiness in the test. So it basically will retry the tests. If they fail, it reports it. If they hang, it gets a stack trace and kills it. And if they crash, it gets a stack trace and moves on. Basically, and it also deals with infrastructure failure. So if the simulators fail to boot, then it kills them, restarts them, tries again, reports it, and it's all happiness so far. And that's about it. And if you have any questions or want to know more about what we're doing, come talk to me, find me, I'll be around.
Cool, thank you so much, Oscar. So, I was working on product infrastructure when this 1% mysterious failure was happening. So now I know why. So thank you, Oscar, for explaining that. I'm also a very big fan of happy build failure. When I was doing development, nothing bothered me more than an ambiguous error message that I don't know what to do with. So thank you so much. Next up, we have Nima Dini. Nima started here at LinkedIn as an intern. This is actually his first job. Now he's a senior engineer. He got his master's from UT Austin and is working on his PhD also at UT Austin. Nima doesn't know this yet, but I also am a UT Austin graduate, so go Longhorns. Yoo-hoo, honk 'em horse. So he's here to talk about uniform product development experience here at LinkedIn. He works on the AMP multi-product team. Welcome, Nima.
Good evening. This is going to be the last talk. Hope you are still awake. I'm Nima. I work at the multi-product team, and my talk is going to be about multi-products. I want to tell you what they are, how they enable engineers at LinkedIn to be more productive, and how they assist us with automation and continuous integration. At any software enterprise, one fundamental question is, how would you organize your code base? Would you rather have a single giant repository that hosts the code base for all of your products, which is called a monorepo, and companies like Google do it this way? Or would you have a separate repository for each product, which is called a multi-repo, and that's what we do at LinkedIn, and hence we created the concept of a multi-product. So multi-product is a separate business entity that is developed, tested, built, and deployed independently. Any multi-product is tied to a version control system, Git or Subversion. Those are the two that we commonly use here. A multi-product is also tied to a build system like Gradle, Bazel, SPT, and so on and so forth, and is tied to a deployment backend if it's a deployable, like the standard LinkedIn deployment, which we call lead, or other deployment techniques like Hadoop or Samza, etc. So essentially, multi-product is an abstraction, just like you saw in the first talk, Newt. So there is also a product spec for a multi-product that users can specify how should their product look like, what are the dependencies, like it depends on what products and how the build should look like, how the test should look like, and all of those details. So we have a command line tool named Mint, or multi-product intelligence. So Mint is a command line tool that allows you to perform common operations on multi-products. For instance, if you want to create a new multi-product, you can open a terminal and type mint product create. And that would prompt you for the product name, the type of the source control you want to use, whether it's Git or SVN. It asks you for the product template. We have a predefined set of templates, and you can also create a template so everyone at LinkedIn can use. And you should also specify the owners, and the product creation automatically happens for you. Like it creates a repository, it assigns it to the multi-product, and it creates like the skeleton for the build system you are using, if it's Gradle, for instance. And now say you want to clone the code base of someone else's multi-product on your machine. You can use Mint checkout that product, and all you need to know is that product name. You don't need to know if that is under Git or Subversion. You don't need to know where it is hosted, like what is the URL. You just type this command and you have a clone of that product. You can start working on it and experimenting with it. And the next step is if you want to build that product you just cloned locally, you just type mint build. Again, you don't need to know the implementation details because of abstraction, what's the build system, what is the build command that's specified in product spec. And if your product is a deployable, you can locally deploy it by running mint deploy. And under the hood, it knows how it should be deployed. So this universal abstraction, this universal interface, Mint, has several benefits. Like for developer productivity, anyone at LinkedIn can clone any product and start working on it, very easy. And anyone that owns a product can specify their own custom commands in the product spec, and Mint would honor that. You can execute it, and you can glue a bunch of your commands together and create new commands and run them. And the benefit of this abstraction for automation and continuous delivery is, I'm going to talk about it now, but before let's look at the development lifecycle at LinkedIn. So first you write code, then you create a review to ask for peer reviews. And at this point, you want to check in your code. So before your code is checked in, there is a pre-commit CI step that essentially does some lightweight validation on your code, some style checking, some version checks, and all those. And after that, your code is checked into the remote repo. And we would trigger a post-commit job, which is a more heavyweight validation, and at the end, it would publish a new version of your product. So let's look at how this abstraction helps in defining what the post-commit step should look like. With this Mint abstraction, a post-commit step is nothing more than a chain of Mint commands. Because you need to, at this point, your product is checked into the remote repository. You need to check out the product, you need to build it, you need to run the test, deploy it, and at the end, you need to publish the new version to a common place named Artifactory that anyone can use. And now let's look at one command that is very popular among developers here. It's called mint wc test or working copy test. After you've done your local testing and development, sometimes you want to test your change in a remote environment to make sure there is no system dependency that like some environment you have on your machine, but it's not present in a standard environment. And this command allows you to do that. So the way it works is, imagine you are working on product P, you make your change, and now you run mint wc test in a terminal. Under the hood, Mint knows what is your source control. Is it Git or Subversion? And based on that implementation, it creates a patch, like a diff that contains your change. It uploads it somewhere to the cloud, and then it kicks off a validation job, which is, again, a chain of Mint commands. You check out the product at the revision the developer was working on locally. You apply the diff that you uploaded, and then you can build it and do other checks. So one of the checks that we do here, which is we find very strong and valuable, is called compatibility testing. And that also happens as part of a WC test run. So let's talk about compatibility testing. So multi-product compatibility testing wants to essentially test that a change is backwards compatible with respect to all the consumers. Here we enforce semantic versioning. It's a very standard schema. And any developer that has a product should honor this contract. So the contract says your versions consist of 3 parts: major, minor, and patch. And whenever you want to make a backwards incompatible change, you have to increment your major version. Whenever you introduce some new functionality in a backwards compatible way, you bump your minor version. And whenever you make some bug fixes, you bump your patch version. For example, if you have this example that product C at version 1.2.3 depends on product P, let's say you make a change to product P. And it's a small change, it's a bug fix. You go to version 1.0.1. And assuming that previously product C, the build and test lifecycle passed, meaning that product C was happy with product P, After this change, it's still the same test should pass. That means the change to P was backwards compatible. And the way to enforce this in multi-product framework in the same WC test example that we saw is because of that universal contract for versioning, we are able to find all of your consumers that depend on the same major version of your product and run their build and test lifecycle in parallel. And of course, this is a very expensive step because for some mainstream products, they have thousands of consumers. But it's a very valuable signal that if you receive that signal, you're confident that your change would not suddenly start breaking some of your consumers. That's all I had. It was a very introductory talk, and find me after. There's going to be a Q&A now, and we can chat after. Thanks.